Chapter 8, our topic is about exploration routing. Now, here's the objectives. Describe the various route types found in the routing table. Describe the routing table lookup process. Describe routing behavior in routed network. Now, here's the introduction. In structure of the routing table. A routing table contains the information necessary to forward a packet along the best path toward its destination. Each packet contains information about its origin and destination. Routing tables provide the device with instructions for sending the packet to the next hop on its route across the network. Lookup process of routing table. When a packet arrives on a routing interface, the router examines the IBB4 header, identifies the destination IBB4 lookup process. In Figure 1, the router examines level 1 network routes for the best match with the destination address of the IBB4 packet. Classless and classful routing behavior. In classful routing, address is divided into three parts, which are networks, subnet, and host. While in classless routing, address is divided into two parts, which are subnet and host. In classful routing, regular or periodic updates are used.
So let's proceed to our next topic, the routing table structure. When we talk about the routing table, it means a set of rules often viewed in table format that is used to determine where data packets traveling over an internet protocol network will be directed. So let's talk about first the lab topology. So let me give a few examples. Imagine that you have computer in headquarters network and computers in branch network. To connect the branch network to the headquarter network, there are a lot of networking devices. Example, two servers and two firewalls. And each firewall is to protect network of the branch and the headquarter. Also, there are switch, layer 3 devices and two routers to take routing between the two sides. It is connected to table for those devices. So that is how a lab topology works. In routing in routing table structure, there are three routers set up. First, the router 1 and router 2 share a common network, the 172.16.0.0 with 16 subnet, and 172.16.0.0 with 24 subnets. And the second router setup is the router 2 and router 3 are connected by the 192.168.1.0 network with 24 subnets. And the third router setup is the router 3 also has a network of 172.16.4.0 with 24 subnet, which is disconnected or discontiguous from the network of 172.16.0.0 that router 1 and router 2 share. So you must be wondering what is network since I mentioned this several times. So when we talk about networks, it comprises of several nodes that hold and transfer data between each other. To determine the optimal route for data to travel, networks employ a system called routing. So network routing examines every possible path that data can take across a network and chooses the route that data will take. That is just a simple explanation of what is a network. So routing table is the heart of making routing decisions. It is important that you understand the information presented in a routing table. So there are routing table entries coming from the following sources. So first is the directed connected networks. So it is added to the routing table where an interface is configured. Second is the static routes added when a route is manually configured on the exit interface is active. And the third is the dynamic routing protocols. It is added when Routing protocols that dynamically learn about the network such as EI, GRP, and OSPF are implemented and networks are identified. So EIRGP means Enhanced Interior Gateway Routing Protocols. It is an advanced distant vector routing protocol that is used on a computer networks for automating routing decisions and configuration. It is used to share routers with other routers within the same autonomous system. The second one is the OSPF or the Open Shortest Path. First, it is a protocol that is one of a family of IP routing protocols and is an interior gateway protocol or IGP for the internet used to distribute IP routing information throughout a single autonomous system in an IP network. So as you can see in the sample routing table in the monitor below, in a Cisco router, the show IP route commands is used to display the IP version 4 routing table of a router. A router provides additional route information, including how the route was learned, how long the route has been in the table, and which specific interface to use to get to a predefined destination. The sources of the routing table entries are identified by a code. The code identifies how the route was learned. For instance, common codes includes first the C or the connected, it means identifies a directly connected network. The second one is the S or the static. It identifies a static route created to reach a specific network. The third one is the I or the IGRP. It allows a number of gateway to coordinate the routing. And the R or RIP, it prevents routing loops by implementing a limit on the number of hops allowed in a path from source to destination. So for the M or mobile, I'm not familiar with this code. Then for the level 1 routes, let's proceed to the level 1 routes. The no shutdown command enables to interface brings it up. This command must be used in interface configuration mode. It is used for new interfaces and for troubleshooting. When you're having trouble with an interface, you may want to try a shut and no shut. Of course, to bring the interface down, reverse the command and just say shut down. This command can be abbreviated no shut. So that is what is level 1 routes. It is as soon as the no shutdown command is issued, the route is added to the routing table. So the Cisco IP routing table is not a flat database. It has a hierarchical structure that is used to expedite the lookup process when locating routes and forwarding packets. The terms ultimate route, level 1 route, and level 1 parent route and level 2 child routes describe the operation and the hierarchical nature of the routing table contents. We're gonna discuss this later on. Verify route is in your routing table. When we talk about route, it refers to the path a data packet travels on a network. The route includes every devices that handles the packets between its sources to its destination, including routers, switches, and firewalls. The show IP route commands, as you can see in the screen, can be seen in the box, used to show the route's routing table. This is the list of all networks that the router can reach their metric, the router's preference for them, and how to get there. So to clear the routing table of all routes, you do clear IP route. So an ultimate route is a routing table entry that contains either a next hop address, IP version 4, or an exit interface. Directly connected, dynamically learn, and local routes are ultimate routes. So when we talk about next hop address, it specifies the next closest or most optimal router in its routing path. Every single router maintains its routing table with a next hop address, which is calculated based on the routing protocol used and its associated metrics. So when we talk also about an exit interface, it contains the information required by the exit routines for processing at each exit point. A pointer to this structure together with the exit point identifier is passed to each exit function. So there are level of routes, the default, supernet, a network that can be discussed or tackled later on. So the level 1 route is a route with a subnet mask equal to 2 or less than the classical mask of the network address. Therefore, a level 1 route can be first a default route. A default route is a static route with the address of 0.0.0.0 with 0 subnet mask. So, zero subnet mask indicates that new bits in the route's network address needs to match the packet's destination address in order to have a match. So you must be wondering what subnet means. It used to tell us how many bits are contained in the network. So the second function of level 1 route is a supernet route. It is a network address with a subnet mask less than the classical mask. For example, a summary address, when we talk about summary address, it is a route advertisement that lists a single route. The range of addresses that match the single route includes the same addresses and multiple other subnet in a router's routing table. So the third one, a function of level 1 route is the network route. A network route with a subnet mask equal to that of the classical mask. Classical mask means it causes a router to use its default routes for any packet that does not match some other route. So for the parent and child routes, a level 1 parent route is a level 1 network route that is subnetted. A parent route can be an ultimate route. So the routing table basically provides a heading for the specific subnets it contains. So each entry displays the classical network addresses, the number of subnets, and the number of different subnet masks that the classical address has been subdivided to. As shown in the figure, it uses a simple three-router network. Router 1 and Router 2 share a common 172.16.0.0 network with 172.16.0.0 subnets. Router 2 and Router 3 are connected by the 192.168.1.0 network. Notice that Router 3 also has a 172.16.4.0 subnet that is disconnected or discontiguous from the 172.16.0.0 network that Router 1 and Router 2 share. The effects of this discontiguous subnet will be examined later in this chapter when we look at the route lookup process. So in the second figure, it shows the parent and child routes, the configuration of the 172.16.3.1 interface on router 2 and the output from the show IP route command. So notice that there is one entry which is the level 1 parent route. So when the 172.16.3.0 subnet was added to the routing table, another route 172.16.0.0 was also added. The first entry 172.16.0.0 does not contain any next hop address or exit interface information. This route is also known as the level 1 parent routes. So the level 2 child routes are also considered ultimate routes because they will contain the next hop IP address and or exit interface. A level 1 parent route exists only when there is at least one level 2 child route. So a level 1 parent route is a network route that does not contain a next hop IP address or exit interface for any network. A parent route is actually a heading that indicates the presence of level 2 routes, also known as child routes. A level 1 parent route is automatically created in any time subnet is added to the routing table. In other words, a parent route is created whenever a route with a mask greater than the classical mask is entered into the routing table. The subnet is the level 2 child route of the parent route. In this case, the level 1 parent route that was automatically created as 172.16.0.0 that is subnetted and one subnet. The level 2 route is a route that is subnet of a classical network address. Like a level 1 route, the source of a level 2 route can be a directly connected network. a static route or a dynamic routing protocol. In this case, the level 2 route is the actual subnet route that was added to the network when we configured the fast Ethernet 0 interface. So 172.16.3.0 is directly connected. So both child routes have the same subnet mask. So this means the parent route maintains the 24 mask. So in this diagram, it illustrates two child networks belonging to the parent route of 172.16.0.0 that has been discussed from the previous topics. So for this discussion, we will use the topology shown in the figure. In using router X with the VLSM configuration shown, we can examine the effect of VLSM on the routing table. Router X has three directly connected networks. All three subnets belong to the class 4 network, classful network 172.16.0.0 and are therefore level 2 child routes. So regardless of the addressing scheme used by the network, classless or classful, the routing table will use a classful scheme. There are several distinct differences with this parent route and its child routes compared to the classful example discussed earlier. First, the parent route of 172.16.0.0 now contains the classful mask of 172.16.0. Classful mask of 16. So in the classful example earlier, the classful mask was not displayed. Also notice that the parent routes states that the child routes are variably subnetted. So like the classful example, the parent route displays the number of subnets, but now it also includes the number of different masks of the child routes. So the final difference between classful and classless network exists in the child routes. Each child route now contains a subnet mask for the specific route. In the non-VLSM example, both child routes share the same subnet mask, and the parent displayed their common subnet mask with common subnet mask. With VLSM, the various subnet masks are displayed with the specific child routes. So that's all about our topic, the routing table structure.
For our next slide, routing table lookup process, the route lookup process. So in a short, to give you a brief about the route lookup process, so what happens when a router receives an IP packet, examines the IP destination address, and looks the address up in the routing table? So how does the router decide which route in the routing table is the best match? What effect does subnet mask have on the routing table? How does the router decide whether or not to use supernet or default route if there is not a better match? So I will answer these questions in this slide. So first, we need to determine or examine the level 1 routes. So step 1, the router begins by finding a network route, ultimate or parent, that matches the IP packet's destination address. Step 2, if the matching network is ultimate route, not including its subnet routes, and there are no more specific routes, this is the route used to forward the packet. Step 3, if the matching network is a parent route, then the subnet routes are looked through to find the best matching route. Step 4, if there is no match of an ultimate or subnet within parent route, then what happens depends upon to whether or not the router is using in classful or classless routing behavior. So what do we mean a match? So unsam dining match in the routing table lookup process. So the first step of the process is one the router begins by finding a network route ultimate or parent that matches the IP packet's destination address. So nasa pangitaon na sa iyang IP packets. What do we mean when we say the route in the routing table matches IP packet's destination address? This is an often overlooked concept that is important to understanding what happens during the routing table lookup process. So what is a match? In order for there to be match between packet's destination IP address and the route in the routing table. So the routing table process compares the leftmost bits in the destination IP address with the leftmost bits in the routing table. So the subnet mask of the route in the routing table specifies the minimum number of leftmost bits that must match. Remember, an IP packet only contains the IP addresses and not the mask. Remember it. If there are multiple routes in the routing table that meet the previous condition, then the route that has most leftmost bits that match the destination IP address is selected sa mo iyang ipilian. This is known as longest bit match. So for in this the second one is router examines level 2 child routes. So now let's take a closer look at what happens when there is a parent route, which of course means there are also child routes. As we saw in the previous slide, in order for there to be matched, there must be a minimum match of leftmost bits between the destination IP address and the parent route. The minimum number of bits that must match is equal to that of the classful mask of the parent route. This classful mask is only displayed when there are VLSM child route. So the find its to examine it is we need to determine step 1 in step by step. So in step 1, the router begins by finding a network route ultimate or parent that matches the IP packet's destination address. Step 2, if the matching network is an ultimate route, not including subnet routes, and there are no more specific routes, this is the route used to forward the packets. Step 3, if the matching network is a parent route, then a subnet routes are looked through to find the best matching route. Step 4, if there is no match of an ultimate or a subnet within parent routes, then what happens depends upon whether or not the router is using a classful or classless routing behavior. So for the next is the router determines classful or classless routing behavior. So we are now going to discuss the difference between classful routing behavior and a classless routing behavior. It is very important to understand that this has nothing to do with classful routing protocols or classless routing protocols. Classful and classless routing protocols deals with how the routers exchange routing information, which is one of the ways routes get entered into the routing table. In our discussion of the routing table, including classful and classless routing behaviors, we are now concerned about how the routes got into the routing table. Instead, we are only concerned with how the routing table finds the best route after the routes get entered into the table. Classful and classless routing behavior, no IP classes and the IP classes commands are completely independent of any dynamic routing protocol which might be used. It makes no difference whether or not we are using classful routing protocols like RIP version 1 or a classless routing protocol like OSPF. So Step 1, to examine its classful or classes routing behavior. Step 1, the router begins by finding a network route, ultimate or parent match the IP packet's destination address. If the matching network is an ultimate route not included in subnet routes, and there are no more specific routes, this is the route used to forward packets. So step 3, if the matching network is parent route, then the subnet routes are looked through to find the best matching route. Step 4, there is no much of an ultimate or subnet within parent route, then what happens depends upon the whether or not the router is using in class 4 or classes routing behavior. So in if classes, then routers hit level on supernet and default routes. So unsa man daing a supernet route. So how does a supernet route get created or propagated? So a super route can be added by creating a static route, which we will do. However, a supernet routes can only be propagated advertised by classes routing protocol. This is because classful routing protocols that do not send in the subnet mask like classes routing protocols. So the default classful mask would be assumed by the receiving router. Supernet routes in the routing tables are treated no differently than any other ultimate routes during the route lookups. They contain a network route and a subnet mask. The only difference is that the subnet mask has bits than the major network classful mask. If both present in the routing table, the major network route will be longer a bit match and be preferred route. So the longest match, level 1 network routes. Best match is also known as the longest match. So the best match is one that has the most number of leftmost bits, so meaning pinakadaghanan, matching between the destination IP address and the routes and the routing table. So in our example, the longest match is preferred route. So in this section, route 3, this is the longest match to IP packet destination. So mo ni ang iyang pilion. So routing table lookup process, finding its subnet mask used to determine the longest match. So in this scenario, PC1 pings 192.168.1.2. So router examines level 1 route for the best match. So iyang ipakita is show, in the R1 is show IP route. So muna iyang nakita sa router. There exists match between 192.168.1.2 and 192.168.1.0/24. Router forward packets out of the serial 000. So if the best match is level 1 ultimate route, use to forward to the packet. So muna yung gipili since this is has the longest match. So routing table. So it's the process of matching. So first there must be a match made between the parent route and the destination IP. So muna gingon na ganina. If a match is made, then the attempt of finding a match between the destination IP and the child route is made. So 172.16.00/16 is level 1 parent route. We see the dotted decimal address here. So the router sees the bits checks the bits for matching starting from the left. So only the bit matches. So more na nung match sa sa duha ani minus sara 1 1. So second bit does not match mass 16 for mass is /16. First 16 bits must match, so router skips this route to moves to the next route entry. So di ni mao yang pilian since di man siya match. Finding a match between a packet destination IP address and the next route in the routing table. So the figure shows a match between the destination IP of 192.168.1.0 and the level 1 on IP of 192.168.1.0/24, then the packet forwarded out to serial. So ano siya? Here's it. See, makita na to nga the first 24 bits are match. Bisag diri sa pikas the 6 bits match too. Bisag sa pinaka may dili siya match. So ang importante is na sa 24 bits that is match on the left. So in other words mo ni iyang pilion. So level 1 parent and level 2 child route. So before level 2 child routes are examined, there must be a match between the classful level 1 parent route and the destination IP address. So this is the sample of kaan. So dapat kailangan kano mag-match ang classful level 1 parent route and destination IP address. So level 1 parent route, header for the child routes. So 3 subnets. Okay. So to makita nila to necessary, we have to show IP route. After the match with the parent route has been made, level 2 child routes will be examined for a match. So route lookup process search for child routes with a match with the destination IP. So mo ni siya di man maklaro, hanap man. Wait. So and step 1, if the best match is a level 1 parent route, proceed to step 2. So if makita na ning best match, proceed to step 2. So the level 2 routes with the same child next. So match with the subnets forward the packets. So how a router finds a match with one of the level 2 child routes? First, router examines parent routes for a match. If a match exists, then child routes are examined. Child route chosen is the one of the longest match. So example, level 1 parent route and level 2 child route. So mo ni ang destination of IP packet is 172.163.10. So iyang bits is money iyang bit. So level 2 child route is 172.168.3.0/24. So first 24 bits are matched to the sa level 1 nga IP packet. So example, route lookup process with VLSM. The use of VLSM does not change the lookup process. So how na giingon, this is as a first sa itong nga slide, if there is an IP is a match between destination IP address and the level 1 parent route, then level 2 child route will be searched. See here in the picture, 172.168.0/16 is variably submitted 3 subnets and 2 masks. So level 1 parent route, so 2 masks. I guess this is the last slide for the routing table lookup process. Thank you.
So hi guys, our topic today is about understanding the routing behavior. So routing behavior is an important task in modern transportation in engineering. So effective management of routing behavior can reduce the travel demand on the straight bottlenecks and thus help to relieve traffic congestion. So nowadays, there is not a standard and large-scale data set collected over long period of time that allow us to characterize route choice behavior. So, moto siya, no? Then, after that, class pool and classes routing protocols so influence how routing table is polluted. Class pool and classes routing behavior determines how routing table is searched after it is failed. So, class pool routing. So, behavior no IP classes. So, what happens if there is not a match with any level 2 child roots of the parents? So, router must determine if the routing behavior is classes or class pool. So, if router is utilizing class pool routing behavior, then lookup process is terminated and packet is dropped. So an example of when classful routing behavior is in effect and why router drops the packet. So moto siya, no? So the destination must in at 24 and none of the child routes leftmost bits match the first 24 bits. This means packet is dropped. So moto siya, no? So there's a classful routing behavior. So unsa na to mailhan og classful routing behavior siya. So the reason why the router will not search beyond the child route. So originally network were all classful. So originally network were all classful, no? That means an organization could submit a major network address and enlighten all the organization router about the submitting. So therefore, if the subnet was not in the routing table, the subnet did not exist and packet was dropped. So moto siya ang pasabot sa classful routing behavior. So sa classes routing behavior, so route lookup process with IP classes is in use. So if classes routing behavior is in effect, then search level 1 routes, then supernet routes check first. So if a match access the forward packet, so default routes check second. Then if there is no match or no default route, then the packet is dropped. So moto siya, no? So moto siya ang sa classes behavior. So napay sa classes nga napay lain. So router begins search process by finding a match between destination IP and parent use routes. So after finding the above method match, there is a search of the child route. So that's all. Thank you.
The summary contain structures of routing table. Routing tables entries directly corrected networks, static route, dynamic routing protocols, routing tables or hierarchical. Level 1 route. Have a subnet mask that is less than or equal to subnet mask for the network address. Level 2. These are subnets of our network address. Routing behavior. This refers to how our routing tables is searched. Classful routing behavior. indicated by the use of no IP class last command. Router will not look beyond router for a last match. Classless router behavior, indicated by the use of the IP class last command. Router will look beyond child router for a lesser match.
That is all for routing protocols and concept, chapter 8, the routing table, a closer look. Thank you and have a good day.